Good morning, everyone, or afternoon, depending when you're watching this. Today we're looking at multiple representations of linear relations, okay? So what we're going to look at here is basically three different linear relations and see how they compare and what we can analyze from the graph, and then also look at the equations afterwards. So right now what we're looking at is a detention buyout, okay? So at the school, you may not know, but you can pay the vice principals or principals a certain amount of money, and they will get you out of so many detentions, okay? First of all, Mr. Power, if you pay him $160, you will get out of all detentions no matter how many you have, okay? Second is Mr. Baggio. He just costs $20 a detention. So you just need to see him when you have detention, pay 20 bucks, and then you get out of it, okay? Miss Harnerine, she needs something up front, and she's going to need $100 up front, and then you just have to pay her $5 per detention. Okay, so the question is well, we have some students in the class who have detentions every once in a while. So let's say we have Cameron. He gets about 5 detentions a year. We want to find out what would be the best deal for him. Savannah gets 9 detentions a year. Savannah has a problem with authority sometimes, but not all the time. So she gets about 9 detentions a year. And Madison, well, she struggles. She struggles with yelling at people and everything like that. So she gets about 25 detentions a year. And I really hope you know that I am joking. I am joking about all of this. No, you cannot buy detentions from the vice principals. And no, these students do not get detentions on regularly. I'm just making this up so we can analyze the linear relations. Okay, so now that's out of place. Now let's take a look at the independent variable, okay, and the dependent variable. Well, let's first list our variables. Well, our variables here are the cost and the number of detentions. So we have two variables, the cost and the number of detentions, okay? Well, the cost depends on how many detentions you get. So the dependent would be the cost, and I'm going to put that as C, and the number of detentions, I'll call D, is the independent. Okay, so as we do a table of values, we always have our independent on the left side. That would be our D, number of detentions, and our cost on the right side, or our dependent. So our independent and then dependent, okay? So we have detentions and cost, detentions and cost. Now, I fully expect that a lot of you may not have a printer at home. I just got ink for mine. So if you don't have a printer, that's fine. Follow along. Make these table of values on your own, on a scrap sheet of paper or a line sheet of paper. That would be best, okay? When you're doing this, this is a lesson that you're going to need to pause and restart again so you can try to make predictions and get caught up in the work, okay? So, the number of detentions for Mr. Power, okay? Well, Mr. Power is 160 bucks for unlimited detention buyouts. So, if you sign up with Mr. Power and you give him on September 3rd 160 bucks, it doesn't matter how many detentions you get. You always have paid him 160 bucks. So, if you get 0 detentions, you pay him 160. If you get 2 detentions, you pay him 160. 4, 160. And I think you see where this is going. No matter how many detentions you get, you're going to end up paying him $160. Okay? So now let's use, I believe orange will show up for Mr. Baggio. Yes, that shows up. Okay, so Mr. Baggio, well, we're going to put the same amount of detentions down. 0, 2, 4, 6, 8, 10, 12, and 14. So Mr. Baggio, it does depend, okay? He is $20 per detention. Therefore, if you get 0 detentions, you owe $0. If you get 2 detentions, well, you would pay 20 for one and 20 for the other. 20 and 20 make $40. If you get 4 detentions, 20, 20, 20, 20, you're going to end up paying $80. And do you see the first difference here? Okay, we're always going up by 40 because we're always going up by 2 detentions. And 2 detentions cost $20, $20, $40 each. So now we can just follow our pattern: 40, 80, 120, 160, 200, 240, and 280. Okay? Now, Miss Harnrein, let me see, pink or purple? What shows up better? I think purple shows up better, so we'll go with purple. Okay, so Miss Harnrein, well, we're going to do the same amount of detentions. 0, 2, 4, 6, 8, 10, 12, and 14. Now remember, Miss Harnrein, she does cost some money up front. She wants $100 from you right at the start. You have to pay $100 plus $5 of detention. So if you sign up with her on September 3rd, you give her $100, okay? But now, but now you have to also pay per detention. So if you get 0 detentions and you signed up for her, well, you still owe her 100, okay? Now if you get 2 detentions, well, you paid her the initial 100, plus you gave her $5 for the first detention and $5 for the second detention. That's going to cost you $110. Okay? 4 detentions. Well, it was the initial 100 plus 5, 5, 5, and 5 for 4 detentions. So that's going to be $120. Okay? And as we go up, again, we have a pattern going up by 10s because it's going up by 2s. Because the detention's going up by 2s, this is going up by 10s. Okay? So 120, 130, 140, 150, 160, and $170. Okay? So, now, let's take a look at the actual graphs. Okay? Well, actually, no. I'm going to write the equations right now. That comes on later on the next page, but I'm going to write the equations right now. First of all, for Mr. Power, well, we have an initial value plus the rate of change. You can see here, his goes up by 0, by 0, by 0, by 0, when it goes up by 2 detentions. So his rate of change would equal 0 over 2, rise over the run, which just equals 0. So remember, in our equations, we have the cost is equal to the initial value plus the rate of change times our other variable. In this case, it would be a D. Okay? So Mr. Powers is cost is equal to $160 up front plus 0 times D. But anything D is, if it's 2 detentions, 2 times 0 is 0. If it's 10 detentions, 10 times 0 is also 0. So Mr. Powers is actually a real bit of a different equation. It's just going to be equal C equals 160. If you want to leave the 0 times D in there, that's fine. It's just not needed. Mr. Bagios. Okay? Well, Mr. Bagios follows the same. The initial value plus the rate of change times D. Cost is equal to the initial value of Mr. Bagios is 0. The initial value comes when our independent is also 0. So $0 plus, and his rate of change, you can see it goes up by 40, by 40, by 40, by 40 each time, but it also goes up by 2 detentions. So my rate of change is equal to my rise of 40 over my run of 2 detentions, which just equals 20. 40 divided by 2 is 20. So his, and you can get that from right here up in his. So his would just be 20D. $20 times the number of detentions. And again, that 0 is not needed. You can leave it like that, or you can write it as C equals 20D. It's the same thing. And back to Miss Harnrein. Well, Miss Harnrein, she does have an initial value. Cost is equal to, so if I'm going by the cost is equal to initial value plus the rate of change, the initial value here is $100. $100 up front. Her rate of change goes up $10 every single 2 detentions. So the rate of change is equal to the rise over the run, and the rate of change is equal to the rise is 10, the run is 2, 10 divided by 2 is $5 a detention. Just realized you couldn't see that. Okay, sorry. So the rate of change is rise over run. The rate of change is 10 up 10 over 2. Then that just leaves the rate of change is equal to 5. So Miss Harnerines is $100 plus 5 times the number of detentions. Okay? Now I'm probably going to do this video in 3 parts. We've already been 11 minutes and I don't want to lose it, so I'm going to pause this here and call it part 1. Also gives you a chance to pause and try to get caught up with everything we've done so far. Maybe it's the best idea to rewatch that, and therefore you can see everything that's going on and how I came across all of that. Okay, I'll be back in a minute.